you have your calculators out? You're going to need the calculators again today. All right, so we've been doing sine of an angle, cosine of an angle, and tangent of an angle. Type in sine of 40 in your calculator. Sine of 40. Sine 40, and then hit enter. Everybody should get 0.643 approximately. Yes? All right. Now, we're going to use the second key. And then that's going to get us that little, most of your calculators have that, like a blue, have it in blue writing, or what other colors you guys, I don't know. Whatever color is written just above the buttons, whatever color yours is, you have to hit second to get those, right? And so hit the second key and then sine. Everybody good? Second, sine. And you should get a sign with a little -1 up above it. Do you see that? See that button? And then you're going to type in 0.64. Let's go 0.6427. 0.6427. What'd you get?
40.
About 40, right? If you rounded it, would you get 40? So, do you see any relationship? If the sine of 40 is 0.643 and the sine inverse of 0.643 is 40, they must be inverse operations of each other. Okay, that's a fancy word. We sometimes will say opposites. Not quite accurate. All right? Pause what you're doing. Watch up here. Let's talk about some other inverse operations you've learned before. Back in second grade, okay? 2 times 5 equals 10. And then the next thing you learn, 10 divided by 5 is 2. Oh, multiplication and division are inverse operations of each other. What is 5 squared? 5 squared equals 25. And then your teacher said, well, the square root of 25 is 5. Squaring and square rooting are inverse operations of one another, right? If I say x squared, nope, let's start off easier. If I say 5, let's take it to algebra, 5x equals 10. I don't know if you've stopped and thought about it. We did when we did algebraic proofs, we had to give a reason for this. We divide both sides by 5 because division is the inverse operation of multiplication. To get rid of multiply by 5, we divide by 5 because they are inverse operations of one another. Are you with me so far? Okay. So we cancel those out and get x equals 2. What about x squared equals 25? I wouldn't divide by anything here. I'm not going to divide by anything here because there's no multiplication that I need to undo. What process do I need to undo? Squaring. What's the inverse operation of squaring? Square rooting. By definition. So what I'm trying to say is today, if we have a triangle, and this is angle A here, and let's say this is 5 and this is 3. I don't know. What is the tangent of angle A? Come. What's the tangent of angle A? 5/3. We haven't seen this yet. We haven't seen, I should be more clear. We haven't seen solving for an angle yet. Do you agree every problem we've done with sine, cosine, and tangent has been solving for a side? Solving for a side. We started off Pythagorean theorem. 2 sides, find the third. Then we started off with an angle and a side, find a missing side, right? Today we're going to find how to solve for an angle if you know 2 sides. All right? So that's going to be our process today, and it's called inverse trig. Inverse trig. All right? So looking at the given triangle, which angle has a cosine of 0.5? So the cosine of what angle is 0.5? Isn't that the question we're answering? What angle should we put our pencil at that has a cosine ratio of 0.5? Which angle? It's never going to be the right angle. Remember, it's always going to be one of the acute angles. Should I put my pencil at A? Should I put my pencil at A? Let's check. Let's test it out. Cosine is adjacent over hypotenuse. What's the adjacent side? Ryan, would you shut that for me? Thanks. Radical 3 over 2. Adjacent over hypotenuse. Is that 1/2? No. All right. Let's try my finger at angle B. What's the adjacent side? What's the hypotenuse? 1/2. 0.5. That's it. So what angle has a cosine of 0.5? B. So the cosine of B is 0.5. Do you agree? Now, can you all, even if you don't know what's going to happen, can you all agree? If we wanted to solve for angle B, we're not going to divide by something. We're not going to square root both sides. What's being done to angle B? A cosine is being taken, correct? Do you agree we're going to have to get rid of cosine? Can you all agree with that? Whatever that is, we're going to have to get rid of the cosine. It's not wanted over there. We want angle B over there. Just like when I had x squared equals 25, I didn't want it to be squared. I want it to be just x. Pretend this is just x, okay? We want just an x there. All right. So if I know what the cosine or sine or tangent is of a particular angle, I can figure out what the measure of that angle is. This is called an inverse trig function, all right? Just like square rooting was the inverse of squaring, just like division was the inverse of multiplication, they have their own inverse functions that undo them, all right? So here's how they look, okay? This looks kind of confusing. It's not that bad, okay? Inverse tangent. If I wanted to find angle A, this isn't filling. This is already filled in for you, isn't it? Oops. If I want to find angle A, I know tangent has the ratio of what over what? Opposite BC over adjacent AC. So I'm going to get to this in just a second. Okay? I'm going to show you where this came from. It's going to help you out. Do you agree that tangent, just like we've been practicing, the tangent of angle A is BC over AC? I bet everyone in the room agrees with that. I didn't put numbers on the picture, but in general, BC over AC. Don't I want to get angle A by itself? Because these sides are going to be numbers in this case. We're solving for an angle. The sides are going to be numbers. What gets rid of a tangent? Tangent inverse. And if I have to do it to the left side, I have to do it to the right side. Just like square rooting, I had to do it to both sides. Just like dividing by 5, I had to do it to both sides. Here's what it looks like. I'm going to keep everything in red. And I'm going to show you the operation that goes on to both sides. If I tangent inverse the left side, I have to tangent inverse the right side. That's a parenthesis, just the smart board's glitching out. Do you agree I did it to both sides? I kept the red. I did the tangent inverse to both sides. By definition, if I had 5x and I divided by 5, what happens to the 5's? Cancel. If I have x squared and I take the square root, by definition, what happens? They cancel. If these are inverse operations, and I'm telling you they are, then when I take the tangent inverse of a tangent, what happens? They cancel. What am I left with on the left side? A. And on the right side, I have an operation. Just like when I square rooted the right side, there was an answer that came with it. The square root of 25 was 5. Okay? This has an operation with it. And this is going to go in our calculator. Tangent inverse of the opposite side over the adjacent side. BC over AC in our picture. Come on. Terrible timing. Now, it's written in a different order. It's written in reverse order, but you guys agree it's the same as what I just got down here. Okay? So eyes up here for just a second. We started with a statement we all agreed with 2 sections ago. 9-4, the tangent of A is this side over this side. We all agreed with it. And I just showed you a new operation. I showed you how to solve for the angle. We took a tangent inverse of both sides. This side cancels, we get A. This side's going to go in our calculator, we're going to get a number. What are the units going to be for these answers? Any ideas? Good, it's an angle. So the units are going to be degrees. We're actually finding what the measure of that angle is in degrees. Our answers are going to be angle measures. What were our answers yesterday? Side measures. Today, angle measures. So now after today, no matter what triangle they give to us, we're going to be able to find all of the angles and the sides. We'll be able to solve the triangle. All right? So our calculators will take care of this. Let's do a quick little practice. Just to practice what it looks like to type it in the calculator. And after a while, we're going to do some shortcuts. We're not going to show every single step. Just like when we divided by 5, we didn't always show cancellation. We would just show the answer. What needs to happen to get rid of this tangent over here so we can find angle A? Inverse tangent, right? Inverse tangent. Tangent inverse, both sides. So if I tangent inverse the left side, I have to tangent inverse the right side. Bless you. What happens on the left side? What happens when you tangent inverse the tangent of A? You get A. And on the right side, we'll have to type it in our calculator. Don't do regular tangent. Hit second tangent and then 0.75. What do you get? 36.87. We'll write that out first, and then we'll have to look to their directions to see if they tell us how to round. 36.87 degrees. So Olivia said 30. You said 36.9. Mm-hmm. Yeah, they'll tell us to round to the nearest tenth sometimes, hundredths other times, or whole degrees sometimes. Okay, so you'll just have to decide based on what they tell us. And again, I put degrees there because A is an angle. Now, what does this mean? Real quick, it's important you guys understand this. Here's a triangle. Here's a right triangle. This is only used for right triangles for now. This is saying, like, if this is angle A, the opposite to adjacent ratio is 0.75. I can think of some sides that have a ratio of 0.75. What's another name for 0.75 as a fraction? 3/4. So maybe the opposite side is 3, and the adjacent side was 4. Do you agree? Is the tangent of A 3/4? Yes. What about 6, and 8. 6 over 8 is also 3/4. How about 12 and 16? No matter which of those triangles we're talking about, scale factors, angle A is about 37 degrees. Angle A is about 37 degrees. Does that make sense? We just solved for that angle. This is what's happening when you type that in your calculator. You're finding the angle that had that opposite to adjacent ratio of 3 to 4. Next one. What do you think is going to get rid of a sine? Inverse sine. And if we do it to the left side, we have to do it to the right side. What happens when you sine inverse a sine? By definition, they cancel. We have angle B. And the right side goes in our calculator. What is the answer? 60.46. And what would the units be on that? Degrees. Do you understand what's going on? Everybody lost? Last one. I'm going to skip a step if you're okay with it. What do you think gets rid of a cosine? Cosine inverse. It has its own button. And if I do it to the left side, I have to do it to the... What do I get on the left side when they cancel? C. What goes in my calculator?
Inverse of cosine.
Cosine inverse of 0.15. And what is that as an angle?
81.37 degrees.
Thank you. That's going to be our last step when we do these problems. Okay, for today, that's going to be our last step, is typing that in our calculator to uncover the angle that had that ratio. All right. So our next, I think this is our next fill in the blank for the notes. To solve a triangle, you have to find all the unknown side lengths and angle measures. You can solve a right triangle when you know either of the following: 2 sides, or 1 side length and the measure of 1 acute angle. Now, I'm kind of glossing over the fact that we already know it's a right triangle. All right, we already know it has a right angle. If you're a math person, you're going to enjoy this stuff. It's like a puzzle. You got to find all the missing information. Maybe 2 angles. Maybe, any combination of those. If you know 2 sides, you have to find the third side, and then 2 angles, right? If you know 1 side and an angle, you have to find the other angle and 2 sides. So it's going to be some combinations of those. Did you have enough time to write that down? Awesome. Let's get into it. Let's get into this. All right. Now, here's one scenario. They give you 2 sides. Do we all agree we can use the Pythagorean theorem to find the third side? Mm-hmm. What's the hypotenuse in this problem? 2, 3, or C? Yeah, so I'm going to go ahead and label. I told you guys earlier to highlight it or label it. It's going to help you, and it's going to even be more important right now when we're combining everything we've learned so far. So step 1, I would probably solve for the hypotenuse. So 2 squared plus 3 squared equals C squared. 4 plus 9 is 13. What gets rid of a square? Square root, both sides. So C is the square root of 13. And if they asked us to write it as a decimal, it's going to be 3.13. 3.61. 3.61. So on a quiz, you may be like, it may have answer lines. How many pieces of information are going to be on those answer lines if they ask us to solve the triangle? How many sides do we have to find? We have 2 of the 3 already. So how many sides are we going to have to find? 1. So they might say side C or side AB is blank. How many angles do we have to uncover?
2.
The measure of angle A. And the measure of angle B. So we've already done side C. It was 3.61. Now, I feel pretty confident in that, but I will admit, it's a rounded answer. And if I need to use 2 sides for any calculations in the future, I probably want to stay away from that side just because it's rounded. And if I type something in accidentally and got it wrong, I don't want to use that wrong answer in my future calculations. You understand that? Okay. So now we're going to uncover some angles. So if you're a step person, step 1 was use the Pythagorean theorem to find the missing side. Is that going to be the case every time? No. Only if they give us 2 sides. If they gave us an angle and a side, you can't use the Pythagorean theorem then. Step 2, find either angle A or angle B. It doesn't matter. All right? And like I said, decide which trig ratio you're going to use that will not use the side we just found. All right. Chase, pick an angle, any angle, to find A or B.
A.
Good choice. It didn't matter, by the way. He could have said B. All right. Angle A. Well, I'm going to teach this the same way I taught you sine, cosine, and tangent. Put your pencil on the angle. But I'm not going to say put your pencil on the angle that they gave us. Remember how we had to put it on like the 30-degree angle or the 40-degree angle, whatever it was, and then this side, sine, cosine, or tangent. Now we're going to put our pencil on the angle we want to find. It could have been A, could have been B. Chase chose A. So here we go. My pencil finger is on A. Decision time. I don't want to use this side. I'm not going to use the hypotenuse. Right? I don't want to use that because that's one we had to find. So guess which 2 are out right now? Sine and cosine both use hypotenuse. They're out. It's got to be tangent. Right? Because aren't the 3 and the 2 the opposite and the adjacent sides to the angle I'm trying to find? So let's write a ratio using tangent since we're trying to find angle A. The tangent of A. The tangent of A is what over what? 3 over 2 or 2 over 3? 3 over 2. Now our next step is the thing we've been practicing. What gets rid of this tangent so we can get A by itself? Tangent inverse or inverse tangent, right? And if I do it to the left, I have to do it to the right. This is so maddening. All right, tangent inverse. Tangent. And this is math. Okay, every teacher ever in math says show your work. I know you can like skip a couple steps here. I want to see these steps for now. Okay, you're just learning this. You haven't practiced it long enough to be able to skip steps. All right, tangent inverse of a tangent gives us angle A. And the tangent inverse of 3 over 2 goes into our calculator. Second, tangent 3 divided by 2. And I noticed some of you guys are using the A, B over C button. Don't. Actually type in 3 divided by 2. Okay, 3 divided by 2. Tangent inverse of 3 divided by 2, I'm getting 56.31 degrees. Are you getting 56.331 degrees? 56.31 degrees. Jackson, question.
Oh no, I had the answer.
Oh.
For that.
Thank you. Is that what you got?
Yeah.
Perfect. Everybody understand how to uncover that angle? Now, quick little check. What's the tangent of 20? What's the tangent of? I can't say it. The tangent of 56.31. What's the tangent of 56.31? Regular tangent, not inverse. What's the regular tangent?
3 over 2.
3 over 2. Should be. The tangent of 56.31, is it about 1.5, which is 3/2? Yes. Are we pretty confident in our answer? Yes. So we just found a side and now an angle, 56.31 degrees. What's the last thing we need to do to solve the triangle?
Subtract 90 from 56.31.
Don't we just have one more angle to find? Aren't these angles complementary? 90 minus 56.31. Did you get 33.69?
Yeah.
33.6. Now, I'm going to let you do that. I'm going to say it again. I'm going to let you subtract 90 minus the angle you found to get this angle. Do you agree? You could do the same process we just did to uncover angle B. Pretend it's not there. Ready? Put our pencil on angle B. What ratio are we going to use if we want to use the opposite and the adjacent? Tangent again, right? Tangent? Isn't the tangent of B, it's not 3 over 2 this time, it's opposite over adjacent. Do you agree it's 2 over 3? How do you uncover angle B? What gets rid of the tangent? Tangent inverse. Tangent inverse 2 over 3. Would you look at that? 33.69 degrees. So if you want to be sure and you want to show your work for that third angle, you could do the tangent again with the missing angle instead of just subtracting the angle from 90. Because do you agree? If this angle is wrong, subtract it from 90, you're going to get that angle wrong too. That's a choice. Last problem for today. I actually want to do this one, but let me walk you through this one, okay? I want to get to this. We'll get to this tomorrow. Pythagorean theorem to start? Yes or no?
Yes.
Yeah? What would you be careful of?
You're not finding
You're not finding the hypotenuse. So it's going to be x squared plus 24 squared equals 25 squared. All right? We're not going to solve it, but Jared, what angle would you want to find first?
X.
Okay, if Jared wants to find x, my pencil goes here. What two sides am I using? The
opposite
adjacent and,
hypotenuse,
this time I wouldn't use tangent, I would use
cosine.
cosine. Adjacent hypotenuse, I would use cosine. What uncovers a cosine? cosine inverse. Do you see how you would do that one? Okay. I want to do one that's a little different. Not two sides, but an angle and a side. Okay. Can I use the Pythagorean theorem to start here? No. So I'm going to have to find the measure of angle G. I'm going to have to find side, well, they called it H, and G. How do I find angle G? Good, 90 minus 25. What's 90 minus 25?
I have a question.
Real quick, I'll get to you in just a second. What's 90 minus 25? 65. Go ahead, Tyler.
So solving the triangle is just finding all angles and sides.
Yeah, finding all the missing parts. So there's 3 angles, 3 sides. Whatever's missing, we're solving for. All right. I want to use that 25. I'm confident in that 25. Again, there's choices here. Josh, we found the angle. What side do you want to find next, Josh? G or H?
G, I guess.
G? Good choice. It didn't matter. All right. I have my pencil on G because that's what he told me to pick. Or I have my pencil, I need to back up, on the angle they gave us. And I want to use G because that's the side he picked. Are you with me? So we're back to a problem like in 9.4 and 9.5 now, aren't we? Okay. Josh, what 2 sides do you want to use?
2 sides.
Which 2 sides am I going to use if you want to find G?
The HJ and then HG.
Good. Well,
Mm-hmm.
this is the hypotenuse.
Mm-hmm.
So this one's the
Adjacent.
adjacent and the hypotenuse. That tells us we're going to use cosine. So the cosine of 25 degrees. Did you notice it's not the cosine of H? Because they actually told us what H is. They told us it's 25. Josh, is it G over 13 or 13 over G?
Or G over 13.
Good. It's adjacent over hypotenuse. G over 13. Do I need a cosine inverse in this problem?
No.
We're going to say it again just for repetition. Do I need a cosine inverse in this problem? No, because we're not solving for any angles. Are you with me? This is a regular sine cosine tangent problem. I multiply by 13 on both sides. I get G equals 13 times the cosine of 25. $13 times regular cosine, not inverse, 11.78. So G is 11.78. We're going to run out of time, but how would I find that third side? Could you do the Pythagorean theorem now? Yes, all eyes up here. Could you also do opposite over hypotenuse and use sine? Regular sine or inverse? Regular, because we're not solving for any angles. All right? That's how you would solve the triangle. All right, I'm going to double check the homework for tonight, make sure you guys are able to do all those. What do you guys think of that so far? Not bad?
But the science test, it's just over all that weekend stuff, right?
I'm going to make 20 through 22 optional for now. Just 20 through 22 are optional. Is that clear? Is that clear? Which ones are optional? McKenna, which ones are optional? Which ones are optional? Good. Preston, which ones are optional? Very good.
It's snowing. I need to.
Have a good day.
Jared, you want me to get you?